So our final speaker of the day is Dr. Emily Bamforth, who's the curator of the Philip J. Currie Dinosaur Museum in Wembley, Alberta. She completed a BSc with specialization in evolutionary biology at the University of Alberta, which sparked a fascination in the origins of multicellular life on Earth. She went on to do a master's degree at Queen's University in Kingston, Ontario, under Dr. Guy Nabour. Her fieldwork in Mistaken Point, Newfoundland, explored fossils of the oldest complex multicellular life on the planet, from which she describes 3 new species. Returning to her first love, dinosaurs, Dr. Bamforth completed a PhD at McGill University in Montreal under Dr. Hans Larsen, with a thesis based on the dinosaur mass extinction in Saskatchewan. After graduating in 2014, she went on to work as paleontologist with the Royal Saskatchewan Museum, where her research focused on late Cretaceous and early Cenozoic paleoecology and paleobotany, as well as mass extinction. She began as a curator of the Philip J. Currie Dinosaur Museum in 2022, where her work focuses on late Cretaceous paleosystems, with an emphasis on understanding the relationships between paleoclimate, paleobotany, and dinosaur ecology. Dr. Bamforth is adjacent professor at the University of Alberta's Department of Biological Sciences and the University of Saskatchewan Geological Science Department, and enjoys working with graduate students. In her free time, Dr. Bamforth enjoys hiking, photography, volunteering at her local art center, and singing in 3 choirs. And she's also APS vice president and organizer of Awesome Field Trips.
Actually said. So thank you very much. When I put this talk together, I had no idea that talking about dinosaurs that are made in Canada was going to be so timely. Yes, today we are going to be talking about some spectacular dinosaur fossils from Canada, particularly those of T-Rex and their contributions to science. So the T-Rex, of course, needs no introduction. Everyone is familiar with this beautiful, friendly face, the Tyrannosaurus rex. Name, of course, means tyrant lizard king. And what drives me nuts is how it's often shortened to T-Rex. I'm sure every paleontologist gets driven crazy by that. T-Rex is a binomial name, so that's why it has the dot. So T-Rex is one of the most famous dinosaurs of all time, the most popular dinosaur of all time. If you were to go on and ask the average Joe on the street to draw you a dinosaur, almost guaranteed they would draw you a T-Rex. So T-Rex was officially named in 1905 by Henry Fairfield Osborn. Fun fact for your next cocktail party, the Albertosaurus is older. The Albertosaurus was described in 1904. So our Tyrannosaur is actually older than T-Rex. Another reason to be proud to me. So, but T-Rexes are, despite being the most popular, well-known dinosaur of all time, they're actually a fairly rare species. So T-Rex, as many of you know, was actually only around for a very short period of geologic time, for about 2.5 billion years. Yes, that is short for a paleontologist. They're around for about 2.5 billion years, right at the very end of the age of the dinosaurs, in what we call the Maastrichtian period. So they, along with the Triceratops, were one of the last dinosaurs to ever walk the earth. So T-Rex also has a fairly restricted geographic range as well. T-Rex is only known from Western North America, which at the time was actually separated from Eastern North America by the Western Interior Sea, basically cut the continent in half. So T-Rex was only found on the western part of that. So T-Rex was found from a very geographically restricted area, relatively speaking, and was also only around for a very short period of time. But T-Rex was rare for another reason as well, and that has to do with preservation. So this is a cool little thought experiment. So at the top here, we have the kind of a geologic range. You can see the late Cretaceous over here. There's the dinosaur mass extinction. And here's all the time that happened after the dinosaur mass extinction up to us today. There's the ice age there. So let's look at the geologic range of T-Rex. Again, around the very, very end of the age of dinosaurs. They're around for about 2.5 million years. Compare that to where we are today. Anatomically modern humans, that's Homo sapiens like you and me, we've been around for a much, much shorter period of time, about 130 to 150,000 years. So there was this cool study that was done in Science a couple of years ago that wanted to know how many T-Rexes walked planet Earth during the entire time that that species existed. And they could do this study and publish it in Science because they were working with T-Rex. You would not get away with this from something like Utah raptor or something like that. So they took all of the T-Rexes out there, they calculated what the preservation rate, and they decided that in 2.5 billion years, there were about 2.5 billion T-Rexes that lived on the planet. Then you might think, whoa, 2.5 billion T-Rexes? Like, that's a huge number of T-Rexes. The world must have been teeming. But hold on now, let's look at our own species. There are almost 8 billion of us on planet Earth right now at this moment. So at this moment, there are 3 times as many humans on the planet as T-Rexes that ever lived on planet Earth. So if you were to do the math and figure out how many Homo sapiens had ever lived on planet Earth, it's something like 35 to 50 billion. So humans are way, 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 way more common than T-Rexes ever were. So T-Rex, it was a rare animal even when it was alive, and that's even before we take preservation into consideration. So these authors also looked at what is the rate of T-Rex preservation in the fossil record. And they figured out that the preservational rate of this dinosaur was about 1 individual for 80,000. That is, of 80,000 T-Rex, only 1 would be preserved. And when I say preserved, I don't mean complete, beautiful, articulated skeletons. I mean like a shard of a tooth or a tiny bit of a rib. So this is this is a good preservational rate for a vertebrate animal in general. They preserve well because they're big. Bigger things preserve better than little things, generally speaking. But even then, this is not a very good, the odds of being fossilized for a T-Rex were still not very good. So everything that we know about this hugely iconic, popular dinosaur that, of those 2.5 billion T-Rexes that ever lived, everything we know about them is based on roughly 30 skeletons. So there's, we find other bits and pieces. We find a tooth over here. We find a little fragment of bone over there. But if we're talking about skeletons, that is things that are more than 30% complete, there's about 30 T-Rexes in the entire world. And of those, there are fewer than 10 that are more than 65% complete. So those complete T-Rexes that we have are absolutely vital to our understanding of this hugely iconic dinosaur. So now here's a little bit of a pop quiz. I didn't tell you this was going to be an interactive presentation. T-Rex is only one of several tyrannosaurs. So as many of you know, we classify dinosaurs the same way as we classify modern animals. Like, there's the cat family, which is the lions, and the domestic house cats and the tigers, and they all fit into the cat family. Same thing with tyrannosaurs. So there's T-Rex, but it's only one of the members of the tyrannosaur family. So here's your pop quiz. How many T-Rexes are in these pictures? You can answer in your head, it's okay. The answer is there is only one T-Rex here, and that's this guy here. So T-Rex, as I mentioned, was around about 66 million years ago and only found in North America. These other things that you see in here are also tyrannosaurs, but they're either from a different place or a different time period. This guy here is Tarbosaurus. So Tarbosaurus is an Asian tyrannosaur, very, very similar to T-Rex, around roughly the same time, but again, on a different continent. This guy here, you may be familiar with. This is a mount of the Tyrrell Museum. This is Gorgosaurus. So Gorgosaurus is a smaller, older cousin of the T-Rex, and it was around about 74 million years ago. It's about 10 million years older than T-Rex. And this guy here, one of my favorites, this is a Daspletosaur. So Daspletosaurs were fairly large tyrannosaurs. Some of them actually approach the size of the T-Rex. But again, if you look at the time that they're around, they're older than T-Rex by about 10 million years. So the Tyrannosaur family is actually pretty big. It's kind of just a general survey of all of the animals that kind of fit, no, not all of them, a bunch of the animals that fit into that family. And you can see they vary in age. There's some little guys, there's some big guys. There's some that are, those would have been those huge predators in their ecosystems. Some that would have been kind of more in that sort of small mid-predator range. But they're from all over the world, all different sizes. And of all of those, T-Rex was the biggest. So here's another little pop quiz for you, and I guarantee a few of you in the audience will know the answer to this. Where are the majority of Canadian T-Rexes found? That's right. Most Canadian T-Rex specimens come from Saskatchewan. So Tyrannosaurus rex is actually the official provincial fossil emblem of the province of Saskatchewan. There's actually a competition that they put up in 2016. It's actually while I was still working at the RSM, and they had a couple of different candidates, crocodiles, dinosaurs, these big mammals called brontotheres, and to absolutely no one's surprise at all, the T-Rex won. So T-Rex is the official fossil emblem of Saskatchewan, and you might ask, hey Alberta, where's your official fossil? We don't have one yet. We're working on it, but Alberta, ironically, does not have a provincial fossil emblem yet, but as I said, we're working on one. T-Rex is taken though. Saskatchewan already took it. So you might ask, why Saskatchewan? Do T-Rexes just love the Rough Riders and potash and bunny hugs? Are they just all over that kind of stuff? And, well, I mean, maybe, who's to judge? But the answer is no, not really. We find T-Rexes in Saskatchewan because they have more of the right age rocks. So this image in the background, this is beautiful Grasslands National Park, right on the border of Montana and central Saskatchewan. If you haven't been there, you should go. It's one of the most beautiful places on the planet. And these outcrops of badlands you can see, most of them are made up by what's called the Frenchman Formation. So if you were to look into the distance in that picture, you would eventually see Montana. So these rocks go into Montana, but because they cross that geopolitical boundary, they get a different name. In Montana, it's called the Hell Creek Formation. Some of you may be familiar with that. It's one of the best known dinosaur formations on the planet. The Frenchman Formation is the same thing, just in Canada. And these rocks here are full of dinosaurs, mostly Triceratops, but there's a few hints of other dinosaurs in there too. Another cool thing about this area of the world is if you look closely and squint, you can see this black line right there. I'll highlight it for you. That's the KPG boundary, the extinction level of the dinosaurs, where you find that thin layer of ash that represents the fallout from the meteorite impact. You can find it really well all over Grasslands National Park and all throughout southern Saskatchewan as well. So it's a really cool place to work for that reason. But now I want to introduce you to a very famous Saskatchewan T-Rex. This is Scotty. I have a very special place in my heart for Scotty. As I worked at the Royal Saskatchewan Museum for almost a decade, I worked at the T-Rex Discovery Center in East End, and Scotty was basically looking right at me every single workday, right through the windows of the lab. So this is a 3D print of a 3D scan of Scotty's skull. So you can come take a look at that if you want. She is an absolutely beautiful, beautiful dinosaur, known to science as RSKM P2523.8. And Scotty is really cool because we now know that this is the world's largest T-Rex. World's largest T-Rex is Canadian. Let me tell you a little about Scotty. This is a really, really cool specimen. So Scotty was found in the Frenchman River Valley near the town of East End, Saskatchewan. This is the coulee system that Scotty came out of. And this person here, this is Alyssa. She was from the RSM. She is actually digging up a T-Rex right there. It's not Scotty, but it's another T-Rex we'll also talk about. But this is kind of the area that Scotty came from. And again, it's from the Frenchman Formation, those latest Cretaceous rocks immediately prior to the dinosaur mass extinction. So Scotty was actually found on August 18th, 1991. That's the unearthing day. So it was actually discovered by a high school teacher called Robert Gebhardt. Now, high school teachers are really good at finding significant fossil sites. Robert Gebhardt found Scotty. Another high school teacher found the Pipestone Creek bone bed, which is a famous fossil locality up north. Matt Vavrick is a high school teacher you heard earlier today. High school teachers are great for finding significant dinosaur deposits. So Robert was out with Tim Takarik, who was at the time with the Royal Saskatchewan Museum. They were hiking around this coulee system near East End in the Frenchman Formation. And Robert found the first couple of bones. And Tim called Tim over. Tim said, hey, that looks like T-Rex. Unfortunately, it was late in the season. They were pressed for time. They were pressed for resources. And so it was actually 2 years later, in 1993, that they went back to actually take a closer look at these fossils that Robert Gebhardt had found. And as soon as they got there, they started digging. They realized that they had something hugely significant. It was what they initially found was a partial skull of a T-Rex. And they got really, really excited. So the Scotty excavation, I should mention too, Found on private land. These are the family that own the land there, and they've always been incredibly supportive of paleontologists on their land. So a big shout out to the local family that the T-Rex was found on. So the excavation of Scotty, the bulk of it took place between 1993 to 1996. It was an absolutely huge endeavor. A T-Rex is a very, very large animal, so they had to move a lot of rock. Maybe it was however much, 100 tons, I think the Kaskey hadrosaur took to remove. Probably that amount for Scotty as well. Scotty also could not be collected as one block. The specimen was disarticulated, completely disarticulated, so it was kind of spread out over a big area. So they had to make these absolutely huge jackets. The biggest jacket in the Scotty excavation weighed 10 tons, so big that they had to get a team of Clydesdale horses to flip it over. They basically took this team of horses, they attached the jacket, and they got the horses to effectively flip the jacket over. And that jacket was so big, they needed a derailment crane to pick it up, move it over, and put it onto a truck to drive it out of the coulee. So huge undertaking, and it basically took 3 years. There was a couple of, a few years where they followed up with the excavation, but the bulk of it was collected in the early 1990s. So the preparation of the Scotty skeleton, because it was primarily in a rock-hard sandstone encased in iron as well, it took 20 years. So it was 20 years from the excavation to the time that the skeleton was actually exhibited. This is what the Scotty quarry looks like today. So this is decades later. I think I took this picture about 5 years ago. And even though that was at the time 25 years ago, you can still see that it was a gigantic hole in the ground that this specimen came out of. So it was a big undertaking, but again, totally worth it. So Scotty ended up being about 65 to 70% complete. It's up there in the top 5 most complete T-Rexes ever found. And critically, the skull was complete. And so that's really important for dinosaur paleontologists to get the skull. The more of the skull, the better. There's a lot of taxonomic biological information that's kind of incorporated into the skull. So Scotty had a really beautiful, disarticulated but complete skull. And also associated with the skeleton, there was a whole bunch of other material that was found. There were some plants, there were some other vertebrates, there were some invertebrate traces that were found as well. And because of that, from the context that the skeleton was found in, we were able to make some really interesting deductions about the taphonomy of the skeleton. So basically what happened after the animal died, but before it was fossilized. So for example, Scotty is missing one leg. So we think maybe this is kind of what happened. The animal died, it got washed onto a riverbank, started to decay, these little kind of scavengers started to move in, and then afterwards the skeleton was picked up, redeposited, and buried. So there's a really cool taphonomic story in there as well. So this is the really cool thing about Scotty. So Scotty was officially described in 2018. That's where the paper came out that actually described the specimen. So it was led by Scott Pearson. And basically, before Scotty was described, this was considered the world's largest T-Rex. This is a Tyrannosaurus rex called Sue, who many of you will be familiar with. She was collected in North Dakota, and she was actually found just a year before Scotty was found. So Sue, until 2008, was considered the world's largest T-Rex. Today, she is still considered the most complete T-Rex in the world. So now we have Scotty, the paper is 2019, described Scotty officially, and Scotty turned out to be a little bit bigger than Sue in terms of length, but a much, much more massive skeleton. So Scotty now is considered to be the world's largest T-Rex. So when people think of T-Rexes, this is my favorite fact about Scotty. When people think of T-Rexes, they tend to think of them as kind of like this Wolverine-like character, like really fierce and like voracious predator, when in fact, Scotty was a little more like the Dowager Duchess of Saskatchewan. God rest her soul, thank Scott. So how do we know that? So we know that Scotty was an elderly individual. She was old when she died. Sorry, I just used the pronoun. We suspect that she may also be female as well. So how do we know that? So we know that based on the bones. This is what's called histology. So this is looking at dinosaur bones to kind of understand more about their growth and their biology. So one thing you can do with dinosaur bones is you can estimate their age based on these things called lines of arrested growth. A little like tree rings. It's not quite analogous to it, but it sort of works the same way. So we think that Scotty was about 30 to 35 when the animal died, which is old for a T-Rex. So Scotty is the world's oldest T-Rex in terms of the age of the individual. So she was a grand old lady. The other thing we can tell from bone, sometimes, not all the time, is whether or not an animal is female or male. And the reason we can do that is because of something called medullary bone. So in modern birds, of course, modern birds lay eggs. The eggs are made of calcium. And so that calcium comes from the female bird's skeleton. And so in order to prevent herself getting osteoporosis, the female bird will lay down an extra layer of bone. That's an extra layer of calcium for egg laying. That's called egg laying bone or medullary bone. So you can actually see that in histology in a cross section. So there is one T-Rex that's been found that actually has egg laying bone. That means that was a gravid female. That was a female that was about to lay eggs. So that individual for sure was a female. So keep that in your head for a moment. So T-Rexes in general, this is a little bit arm wavy, but bear with me here. T-Rexes in general fall into two morphs. So this, again, we have a very small sample size, but generally speaking, there's a robust morph where we have these like huge, big, chunky skeletons like Scotty and Sue. And there is a grassa morph where the animal is a little more slender, kind of like a less bulky animal. So a good example of this robust morph is Sue. A good example of this grassa morph is this T-Rex called Stan from South Dakota. So that's kind of like just a schematic, just kind of shows you it's a very subtle difference between the two morphs. The morph that had the egg-laying bone was one of these robust morphs. So we think, maybe possibly, again a little arm wavy, that the robust morphs were the females and these grassa morphs were the males. And so that's kind of the rationale behind us thinking that Scotty may have been a really huge female dinosaur. This may sound a little weird to you because we're mammals and we always associate the males being bigger. But if you do look at birds, the female bird will often be bigger than the male. The male will be a little flashier, have brighter plumage, but often the female is actually a little bit bigger. So birds being the closest relatives of T-Rex, this may have also been the case. So we think that Scotty was an old individual. We think that she was female, all 100% awesome. And another really cool fact about Scotty. So you may ask, well, if Scotty, you think Scotty's a female, why was it called Scotty? And funny story, most T-Rex skeletons out there have got a fun nickname. So for example, this one found near Fort Peck in Montana was called the Tex Rex, just because it's kind of memorable. This specimen here, another one of my favorites, a juvenile specimen, was called Jane. So it was named after one of the museum's benefactors. So how did Scotty get his name? Well, because it was found in the back country of Saskatchewan, they were trying to figure out what to call it. And as they were doing this, they were drinking a bottle of Scotch whiskey. So yes, the world's largest T-Rex is named after an adult beverage. So because we're really classy like that. So for better or worse, the name stuck. That is why Scotty is called Scotty. So this is kind of a cool story. Scotty was named after a bottle of Scotch. So it's no surprise that the next T-Rex that was found was called Ginny. So Ginny is another T-Rex that was found in that same coulee system near East End, just about a kilometer away from Scotty. So Ginny is basically just a partial skull of a T-Rex. So you can see here, what's in white in this diagram here is what they have. So it's basically just the lower jaw, so the dentary and part of the quadrate, articulate. Triangular. Anyway, lower jaw, fairly complete lower jaw. But it was also found by a volunteer who was out in the field. This was found in 2004, and it was basically just this lower jaw, and there was a few other little bits and pieces of bone around. So if you remember when I was showing you what the East End Badlands looked like, I said that there was a person there digging up a T-Rex. She was digging up Ginny. So we went back to the quarry a couple of years ago, and we actually found more of the rib fragments from Ginny. So there is some post-crania there as well. Unfortunately, Ginny's bones were really close to the surface when they were discovered, which means that they're not in great shape. The preparator of the RSM has done an amazing job in reconstructing this fossil, but chances are there isn't much more of the skeleton left. It looks like most of the skeleton had eroded away, but we did find the lower jaw. So if you compare Scotty to Ginny, this is a display that's up at the Royal Saskatchewan Museum in Regina, if you ever get a chance to go there. You can see that Scotty is a much larger specimen. We don't know whether Ginny was originally thought to be a subadult. Now we think that we don't know the gender. We now think that the Ginny may have just been a smaller animal. but we're not sure yet. Regardless, we know that Ginny was a small T-Rex. Scotty was a very large T-Rex. And they were almost certainly living in the same environment, probably not at the same time, but the same kind of environment in southern Saskatchewan. So the Saskatchewan has the world's largest T-Rex, in the form of Scotty. Saskatchewan also has the world's smallest T-Rex specimen. So this was a little tiny T-Rex metatarsal, yes, that was found actually really close to where Scotty was found, like within 400 meters. And this is not to scale. This is not the actual size. The actual specimen is just about 2.5 centimeters long. Just this really cute little bone, metatarsal, it's a bone in the foot. So the actual animal itself, this would have been the size of its skull. This is considered to be a hatchling T-Rex. And this is the smallest specimen of a T-Rex has ever been found. This is work that's been done by Eric Snively at the University of Oklahoma. So he's been doing some work kind of reconstructing that little bone, figuring out the venation, imaging it in a way that we can see all of the detail. But it's kind of cool that here in Canada, we have the world's largest and we have the world's smallest as well. So these really little T-Rexes are really important for understanding the ontogeny or the growth of T-Rexes. We now know that T-Rex is a dinosaur that does something incredibly weird in its ontogeny, in its growth. So they start off as these like really stealthy little predators, these long-legged things, probably pursuit predators, so running down, chasing their prey. Recently, there's been a couple that have been found with gut contents. So we know that these little T-Rexes ate other baby dinosaurs, which is kind of brutal. And then T-Rexes have this is like a growth curve from a T-Rex. So they start off as kind of these little long-legged things and they stay that way for a while. And then they have this huge growth spurt when they're kind of teenagers and they get to their adult size. And so they don't really stick around in this middle range here, which is weird. It's a weird growth curve. It's not really something that a lot of animals do, but we think this has to do with their ecology or their biology. So when they're little, these long-legged pursuit predators fit into one ecological niche, and these really big, giant, lumbering ambush predators, the adult T-Rexes we thought were ambush predators, they fit into another niche. And so we think they have this massive growth curve in order to get from one ecological niche to another really fast. So T-Rexes are really weird. They do something incredibly strange with their growth. And these small T-Rex specimens that we find really help us understand what that looks like. But wait, there's more. So we talked about the big T-Rex in Saskatchewan. We talked about the little T-Rex in Saskatchewan. Saskatchewan also has the world's only T-Rex coprolite. So coprolite is fossil poop. So this big poop was found in really close to the Scotty quarry, less than 2 kilometers away. And we know it's T-Rex because of its size. It's kind of about that big, and it is full of crushed up dinosaur bone. So the only predator we had at that time in Saskatchewan was the T-Rex. So this has to have been a T-Rex coprolite. So yeah, Saskatchewan also has some really cool T-Rex specimens as well. So that's kind of the Saskatchewan side of the T-Rex story. Now, by this time, you may be thinking, before I get on to Alberta, if you want to learn more about T-Rexes, absolutely visit the T-Rex Discovery Center in East End, Saskatchewan. It is an incredible building. It goes through all of the discovery of Scotty the T-Rex. You can see a full-scale mount of Scotty the T-Rex there as well. Really, really cool place to visit, as well as just an absolutely beautiful place to go. And it's only a 5-hour drive from here in Calgary. So if you do get the opportunity, definitely go and visit. It is one of my favorite places in the world. If you don't believe me, you can ask these people here, East Enders themselves. It is a really, really beautiful place to go. So if you're thinking of going to California, go to East End instead. So by now you must be thinking, but what about Alberta? This is the dinosaur capital of Canada. We have to have some T-Rexes, right? And you would be right in that thinking. And most of the T-Rexes that we know about in Canada are thanks to Dr. Phil Currie, one of our great Canadian paleontologists, who has been looking for Tyrannosaurs in general, but T-Rexes specifically. And when he was kind of early in his career with the Royal Tyrrell Museum, he was out looking for Tyrannosaurs. And I just want to read you this story. So he published a little account of his kind of Tyrannosaur hunting in Alberta. And they had recently found what they thought was a T-Rex. And they jacked it up. They went out and they had these huge blocks that they were trying to get out of the field. And they didn't know how they were going to get them out of the field. So they called up the British Army, which had a base close by. And this is a quote from Phil Curry. "We could not afford to bring in a helicopter for a single dinosaur, nor the cost of a bulldozer to build a road. We finally sought the assistance of the British Army training at the military base in Alberta. They decided to lift the specimen out of the Badlands as part of a training maneuver using helicopters. On December 19th, 1983, like who collects a dinosaur in December? The temperature was 35 degrees below zero. The visibility was poor because of ice fog, like who flies helicopters in ice fog? As we attempted to get to the Badlands to meet the Gazelle helicopters, one vehicle caught fire and another froze on the road. But everything worked out in the end." And I thought I had few stories. So that's one of Phil Curry's accounts of Tyrannosaur hunting in Alberta. That specimen turned out to be a Displetosaur. So one of those T-Rex-like things, but they're just a little bit older. But Alberta does have at least two legitimate T-Rexes. One is a specimen called the Huxley Rex, or the Huxley T-Rex. And as I was driving down from Grand Prairie, I took a little detour coming to Calgary here, and I stopped by the town of Huxley, which this specimen was named after. It's really close to Trochu, if you guys know where that is. Huxley is a beautiful little place, little hamlet. I did find a place where there are some dead things, but of course, we're looking for deader things in the fossil record. So the Huxley Rex was actually discovered in 1946 by Charles N. Sternberg. So the Sternbergs were a very famous American fossil hunting family. They came here and collected for the Canadian Geographical Survey, now the Canadian Museum of Nature. Charles Sternberg, who was one of the sons, he was out here in the 1940s. He found this specimen and he looked at it and it was encased in ironstone. And he was like, I don't know if there's much there, and gross. Like, and there's tons of overburden. I'm just gonna kick some dirt over that, and I never saw it. But he did make a note of it to his credit. So it wasn't actually until Phil Curry came in 40 years later and rediscovered the specimen. And it was actually good that it was encased in that ironstone because that protected the specimen for 40 years. So 40 years later, the specimen was still there. This time they had lots of jackhammers and enthusiasm. They went in there, they collected the specimen, and it turned out to be a partial skeleton known to science as RTMP 81.12.1, and it's now curated at the Royal Tyrrell Museum. Fun thing about the Huxley Rex, those of you who have seen Jurassic Park, and I hope all of you have, why would you be here if you hadn't? In the visitor center, in the movie Jurassic Park, where John Hammond is taking Alan and Ellie kind of up this big staircase, and there's this T-Rex skeleton right there. That's a cast of the Huxley Rex. Yeah, cool claim to fame for the Huxley Rex. So this is a legitimate T-Rex that was found in Alberta. But there is one that is way, way, way more famous, and most of you have also heard of it. This is Black Beauty. So Black Beauty, RTMP 81.1.6. This is a spectacular dinosaur, T-Rex skeleton from Alberta. The reason it's black is because the bone is rich in manganese, which fossilizes, which in the fossil records manifests as black fossils. So Black Beauty is, again, one of the famous Albertan T-Rexes, also now at the Tyrrell Museum. So Black Beauty was discovered in 1980 by two friends who were fishing on the Crow's Nest River. This is an unusual place to find dinosaurs. It's not necessarily where you would think to go if you were looking for dinosaurs. So it was very fortunate that these friends, in addition to catching fish, they also caught a few dinosaur fossils. So they brought them to their high school teacher, and their high school teacher said, "Hey, I think those are dinosaur fossils." So he contacted Phil Curry, and Phil Curry went out there in the early 80s, realized this is a more or less complete T-Rex skeleton, again encased in really, really, really hard rock. But they went out there, they got the skeleton, and it is articulated. So absolutely beautiful, beautiful articulation in the specimen. And I really like this quote from Phil Curry from his time collecting. He said, "The excavation was arduous." That's an understatement if you know Phil Curry, big into understatements. "But the Rocky Mountain scenery was a nice change from that of the Badlands." And as someone who works in northern Alberta, where we don't have a lot of Badlands, I appreciate that mountain scenery as well. So the area, unfortunately, has since been dammed and flooded, so you can't actually go back to the Black Beauty quarry now. So it's fortunate that they got that specimen when they did. But again, it's absolutely beautiful example of an Albertan T-Rex. And so that is some of the famous Canadian T-Rexes that we have here. And they have made a huge contribution to our understanding, not only of the animal T-Rex, but of dinosaur biology in general. And to finish up here, I just want to mention why these big charismatic dinosaurs are important to science. So, it seems a little cliche to say that you like T-Rex. Everyone likes T-Rex. Why don't you like something really obscure like Jackapil or something like that? The reason is that these big charismatic dinosaurs are a gateway into the hearts and the minds and the imagination of the public. This is what hooks people. This is what gets people interested in paleontology and in science and in learning more about the world and about the amazing history that we have here on planet Earth. So I just want to mention here, these are the 5 most popular dinosaurs of all time: T-Rex, Triceratops, Stegosaurus, this generic long-necked dinosaur, some sauropod, and Velociraptor. So we have a lot, these dinosaurs, we have a lot to thank them for getting hundreds and hundreds and hundreds of people interested in paleontology. Thank you very much.
We have time for some questions.
This is a very important question from a native-born Albertan. Why were they drinking Scotch whiskey? They should have been drinking rye whiskey. And then you could have called it rye. That sounds like a better chance for being a female than Scotty. Anyway, the other question maybe is more scientific, if you want. In the Bozeman, the Museum of the Rockies, they have a series of Triceratops and supposedly T-Rexes. I imagine perhaps you've been there or know about it, but how do you decide whether in fact you got a ontological series or a phylogenetic series?
Really, really good question. So some of you may be familiar with Nanotyrannus, and if you're not, there's a skeleton of one upstairs you can take a look at. There's a big debate in terms of whether Nanotyrannus is a dwarf species of Tyrannosaur or a juvenile T-Rex. And the reason being is that sometimes it is really hard to tell them apart. There's things you can look for in juvenile skeletons, like the skull bones are often not fused. So a lot of time, well, I should say that. Some of the times it's easy to tell, some of the times it's not, whether or not you're looking at an ontological sequence or if you're looking at, say, a dwarf species versus an adult animal. Fortunately, with T-Rex, we have enough skulls that we can tell the sequence. T-Rex is not a super well-represented dinosaur. As I was saying, we don't have a lot of skeletons, but we have enough that we can actually tell. There's many dinosaur species where we don't even have that kind of sample size. So it's difficult. The difference between, is it a new species or is it just a big or is it a new species or is it just a juvenile? This is something that paleontologists consistently struggle with.
I just thought of another question, having been in the Bozeman Museum. They have eggs, and some of the eggs seem to have embryos. Do they know which dinosaurs did that? And could one of them be a Tyrannosaurus Rex? It's probably most of their stuff comes from Hell's Creek anyway.
Yeah, potentially. In the Frenchman Formation, to my knowledge, I don't think we have any eggshell sites, unfortunately.
In Alberta, I know.
In Alberta, there's some from Devil's Coulee, yes, but not as far as we know from Tyrannosaurs, not from T-Rex because it would be too old. But yeah, so that's something I think that we are still looking for. That little metatarsal, though, that was a hatchling T-Rex. So that obviously hatched out of an egg. The egg we think is gone, but we just got the little tiny baby that just hatched out of it.
We shouldn't have to worry because I think Trump doesn't like the smallest of anything.
In regards to gracile versus robust, what would you consider Black Beauty?
I think if I would have to go back and look at literature, I believe Black Beauty was classified as gracile.
Thank you. I know there's been some speculation that Tyrannosaurs, including maybe T-Rex, would have hunted in packs. What is your take on this? And will this be consistent as their body styles and hunting strategies change throughout their life?
Yeah, really good question. So about pack hunting in T-Rex, we know, well, we assume that other tyrannosaurs were pack hunters, like Albertosaurus, for example. If you go to Dry Island Provincial Park, the Albertosaurus bone bed is thought to represent a pack of Albertosaurs. So those animals may have hunted in small packs. The T-Rex, it's unclear. T-Rexes, when they're found, tend to be isolated individuals. So one of the lines of thinking is maybe they were pack hunters as juveniles, and as they got to be adults, they became more solitary. They are huge animals. We know from their skulls that they have a lot of battle scars, like they did a space fighting thing. They just like got into fights and bit each other's face. So possibly really territorial as well. Territorial animals tend to be solitary, not all the time, but often. So I'm not sure where I fall on that. Like I think the fact that T-Rexes generally are found as individuals is compelling evidence they were solitary, but we just need to find more. Like we've never found a T-Rex bone bed, but who knows? There may be one out there.
Thank you.
Eric is getting his exercise.
Just a quick question. Do we have an approximate amount of eggs or young that they might have had at a time?
No. So ultimately for large theropods, we have no idea. We know they had paired ovipositors, so at least two. Probably more like six to eight, but we're not really sure. We haven't found the nests yet.
Hi. Now that a T-Rex is so common in the meme, in cartoons, in commercials, in whatever, but the biggest part of it is the floppy little arms. So what's with the floppy little arms? Like, why? Any idea?
Yeah, so good question. Why the little arms and not just restricted to T-Rex? Like a lot of the Tyrannosaurs have these little arms. And in fact, a lot of the big theropods, those bipedal carnivorous dinosaurs, also have little arms. So ultimately, the reason that the arms are small is because the head is really big. So these things are built like teeter-totters. So the hips are kind of the fulcrum. So as the head gets bigger, the arms have to get smaller to balance out the tail. So that's ultimately where they have little arms. But a good question is, why didn't they lose them altogether? So you think of something like an ostrich or an emu, they basically don't have, they have a little tiny stint of a bone that's a wing, but they don't have real wings anymore. So you'd expect the same kind of thing would happen with a Tyrannosaur. The fact they still have those arms means that they were probably used for something. There's been a variety of different hypotheses that have been invoked, like maybe they're somehow used for mating. I kind of like the theory that they used them when they were lying on the ground to help them get up. Maybe they were really strong. Like that's a very small lever. So they would have been really strong. They could have bench pressed like 200 pounds or something like that. But ultimately we don't really know what they were for, but we suspect they were for something because they were still there.
Hello. I want to ask you a question. How does a dinosaur hunts on different dinosaurs? He is so bulky, strong, and heavy. He can how he can hunt on his prey and still not visible to them?
Oh, how they hunt?
Yes, because in Jurassic Park, in the scene with Tyrannosaurus Rex, we can notice him as a walking prints and vibration. Does a real T-Rex have this ability?
Yeah, good question. So how did T-Rex hunt? So I made reference to the fact that the adults, the big bulky, and they were huge bulky animals, would have been ambush predators. So you might ask, how does something that weighs 8.5 tons, like Scotty, how is that an ambush predator? And the thing you have to remember is these things were forest dwellers. So we often think of dinosaurs as living out kind of out in the bald plain. In fact, they lived in forests for the most part, these kind of like big Cretaceous forests. They probably hung out in amongst the trees and kind of waited for things to kind of wander by. And then they would have done these short bursts of speeds like crocodiles, can gallop really fast. Or, potentially hunted at night. That's another hypothesis that I've heard is maybe they ambush their prey at night. But ultimately, it was because they were living in forests. Like, I don't know how many of you have ever been hiking in a place where there's moose and you've seen a moose suddenly off the trail like 3 meters away, and you're like, I mean, a moose is a huge animal that can hide really well in a forest. Like T-Rexes were possibly the same way.
I also knew this about the systematic camouflage. This like you camouflage your steps and your prey can't notice how far you are. Can you describe this in the details about the Tyrannosaurus Rex, please?
Yeah, so there's a theory. I think it's called acoustic camouflage, and it has to do with the fact that these are really big animals. You know, they wouldn't have made that big booming sound like in Jurassic Park, but there's a suggestion that the way their foot is designed is that it would actually be light, not light-footed, but wouldn't actually make too much of a sound when it moved, just because of how it would have stepped on the ground and kind of lifted its foot. Again, that is still very much a theory, but that is one that's out there.
Just wondering what percentage of the black kiwi fossil is preserved?
Oh, I can't remember off the top of my head. It's relative. It's one of the the top 10 most complete. Anyone out there know? 50%. Yep. Thanks. This is what I like about this audience. Like, who knows the answer to that?
So a number of reptiles, like such as crocodilians or alligators, shed their teeth as an ambush predatory species. Do you think that a T-Rex might have shed and regrown their teeth throughout their lifetime?
Oh yeah, absolutely. So as far as we know, all theropods did. So they had teeth like sharks. They were just continuously replaced.
Do we know approximately how many they could have gone through in their lifetime?
Oh, there are studies that have looked at that. I think what I saw for Albertosaurus was once every 3 months, roughly. So if you do that, like however many teeth they have, and that's why the fossil record is full of theropod teeth and not a lot of theropod bones, which is frustrating. Particularly true in northern Alberta. We get a lot of Tyrannosaur teeth, but very, 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 very few bones of any other part of the skeleton.
Okay, well, thank you very much. Wonderful talk.